Well, these are similar to the last two problems you'll end up seeing on tonight's homework, and what makes them a little bit tougher is that we've got to solve for y. So let's go ahead and take a look at this first equation. I'm going to pull it down over here and just rewrite it because I need to be able to do some opposite operations to get it so y is by itself. So first thing I'm going to do is move that x term over, and so I'm going to subtract that from both sides and rewrite what I've got, and that is a negative 2y is greater than negative 3x plus 6. Well, just one more step, and that is to divide by negative 2. Now remember what happens when you divide by a negative. Lots of things switch. So when I rewrite the equation, it's going to be y is now less than. Make sure you switch that sign because you divided by the negative there. Less than, and then it's going to be a fraction here, so just leave it that way. 3 halves x, and then this will make a negative 3. So now let's go ahead and get right on graphing that one. Negative 3 is the y-intercept, so I go down 3 spaces and then use the slope. So the slope is 3 to 2, so up 3 over 2 to the right. Do that a few times, and we got some points. We could also go the other way, down 3, 2 to the left. Once you've got those points, sketch that line. So this is a dashed line, and then from there we can figure out the shading. So the shading, if we look at the y value, positive y, so again we're not going to use this one up here. This negative y is greater, so it's actually the opposite of a greater. See, positive y is less. Positive y less means below, so you're going to end up shading in this direction, down below the line. The smaller y values is what we'd want. Let's take a look at the next line, and that one already has a y-intercept, and that is negative 3. So it's right there. We go ahead and use the slope. It's 1 to 1. So I do that a few times. You see they do eventually go apart from each other, and it looks like that. And this one here goes out this way, and it goes in that direction. All right, so if I go ahead and carry it out, it comes out like that. And so this is a solid line. I'm going to just extend it past my graph because, again, the whole idea is there's so many solutions you can't even count them. So you want to see the range of values here. You want to see where these lines end up making their different regions. And so there's 4 regions here. There's these 2 small ones, and then there's the one big one to the left and one big one to the right. And so for this blue line, we end up needing to shade, and it says a positive y is greater. So that greater means bigger y, so it's in this direction here. So we're not going to shade in that big area because it doesn't work for the purple line. But it does work in this small little region if we're above the blue and below the purple. And so there is our answer, just that one small region. Well, here's another problem to try that's similar to that. It has, again, another equation that we need to solve for y. So let's go ahead and rewrite that equation. So 3x minus 6y is less than or equal to 12. So what I'll do first is isolate the y. The way I do that is by doing an opposite operation to move the x term over. So I'll rewrite what I've got. And I bring down that negative 6y is less than or equal to negative 3x plus 12. So one more step there, and that is to divide by that negative 6. So when you divide by the negative 6, remember we're dividing by another negative, so we've got to switch some signs. So it now becomes y is greater than or equal to, now watch the fraction here, this is 6 over 3, so that reduces down to 1/2 x. And here, see how the bigger number is now on top, so that's going to make an integer. And so it's going to be negative 2. So if the bigger number is on the bottom, it's a fraction. Bigger number on top, it'll be an integer. Or a mixed number, kind of depending on the numbers. So anyhow, we go ahead and plot those points to represent this graph. This is a negative 2 for the y-intercept, so down 2. Then use the slope, 1 to 2. So up 1 over 2 to the right. You could also go the other way, down 1 to the left. And then from there we can go ahead and draw that line in there. It's a solid line. I'm going to draw it nice and far past this graph here because You never know where it's going to end up crossing. Now, put some arrows at the end showing it goes on forever. And we look at the shading, and it's a positive y is greater. Greater means above, so we're going to shade off in this direction. Let's take a look at the next line, and that has no value being added to x, so we can treat that y-intercept as 0. So we'll put the dot right there and use the slope. Slope this time is -1 to 1, so that means you're going to go down and then to the right. Do that a few times, get on that line. You can also go the other way, up and to the left. And then we can go ahead and sketch in that line. That line is a dashed line. Doesn't have the line underneath, and I see the regions nice and clear. So when I look at this, it's a positive y is greater. So the greater y's are this way. So they're above the line. And so the only region that ends up having true solutions, or any solutions at all, work for both, would be where the two arrows agree. It needs to be above both lines. This would be that region. Let's take a look at the last one here. We have another scenario where we get to practice solving for y. So let's take this equation and just bring it down below. 2y minus 4x is greater than 8. And so the first thing I'm going to want to do is isolate the y. And the way I do that is I take the x term and I move it over. So there's a negative 4x. I'm going to add 4x to both sides. And when I do that, I'm now left with a 2y is greater than 4x plus 8. So I have another step now, and that is to isolate the y by dividing by the coefficient, which is 2. I do that division, and now I do not switch the sign here because I'm dividing by a positive. Notice how the number on the bottom is smaller, so that means it's going to be an integer. It's 2x. 2 goes into 8 4 times, so it's positive 4, and there we have it. So we'll start with the y-intercept, which is positive 4, and go up 4 spaces, put the dot, use the slope. 2 to 1 is it, so we typically go up and to the right. But I run out of room quickly that way, so let's go the other way, down to the left. Do that a few times. And then once we've got a lot of points, let's draw the line. Now this is another dashed line, no line underneath. And then from there we'll draw that arrow at the ends to show it goes on forever. And it's a positive y is greater. That means above. So the greater y's are this way. You can see the y's are getting bigger as you go in that direction. So we say that's above the line. Let's take a look at the next line, and that one does not have an x term. No x term here. So start with the y-intercept, and if there's no x, it makes a horizontal line. The slope is 0 if that's the case. Well, this is another dashed line, so I'll go ahead and draw that dashed line there, arrows at the end, showing that it goes on forever. It's a positive y is greater. Greater means bigger y's is what they want, so they go off in this direction. So the region that works with both, that would show solutions for both inequalities, would be this upper region to the left of the blue line. So above both lines there. So those are some examples of problems that you'll see on tonight's homework.